Okay, so sine of theta equals -7 over 25, and theta is in quadrant 4. So one thing we could say is that since this is like where our angle ends up, the rotation, if we're trying to evaluate cosine of theta divided by 2, think about all the range of possible angles. It's between 270 and 360 degree angle. So if you take 270 divided by, well, it actually, since it's in quadrant 4, it has to be a little bit bigger. So take 271 and divide by 2, then you've got 135.5 degrees, something up here. And then if you take 359 divided by 2, something just a little bit smaller, that's 179 degrees. So there's something we know about cosine of theta over 2. It has to end up in this quadrant over here, somewhere over here. So well, actually, if you just think about any triangle that you draw, the adjacent is negative and the hypotenuse is positive. So our answer is going to be negative. I want to keep that in mind. And then, let's see, we can say something about, now that we know that the answer is going to be negative, cosine of theta over 2, that's going to use this half angle identity. So we need to know what cosine of theta is. This is theta over 2 that we drew. So let's draw theta. Somewhere in the 4th quadrant, they said. And the opposite was 7. That's a -7 because we're going down. The hypotenuse is 25. So if we use a squared plus b squared plus c squared, we should get 24 for the missing side over here. And that's positive because we're going in the positive direction of the x-axis. Let's see. Yeah, so now we know that, now that we know the adjacent, we can say cosine of theta, because this is theta right now. Now we can say cosine of theta is the adjacent divided by the hypotenuse. And now we can plug that into our formula. So cosine of theta over 2, that's going to be negative, because from what we determined at the beginning, -1 plus 24 over 25 over 2. And so when you simplify inside, this is 25 over 25, so you get 49 over 25 divided by 2. So if you flip and multiply, that's 49, divide by 2, that means times 1/2, right? So that's 49 over 50. And then since that's a square root is an exponent, we can apply the property of exponents to rewrite it as 2 separate square roots. And then in the denominator, you can simplify that square root, okay? Because, square root of 49, that's just 7. In the denominator, this is square root of 25 times square root of 2. Kind of went back to where we were before because I know the square root of 25. That's why I rewrote it like that. So this is our final answer. Same approach for this one. Theta ends up somewhere here in quadrant 3 according to this problem. So that means it's somewhere between 180 and 270 degrees. So if it was 269 degrees, and if we divide it by 2, then we're at 134 degrees. So that's as big as it can go. If we take the smallest angle in the 3rd quadrant and divide it by 2, that's 90.5. So we can say something about sine of theta over 2. It has to end up somewhere here in the 2nd quadrant. And because this is a negative direction and this is a positive direction, sine is going to be positive in that quadrant. You could use the mnemonic device. All students take calculus to evaluate that too. All are positive in the 1st quadrant, just sine's positive in the 2nd quadrant, tangent's positive in the 3rd, and cosine's positive in the 4th. So sine, our answer is going to be positive. Okay, so now we got that out of the way. We'll get rid of all this junk. There we go. Okay. Sine of theta equals -4 over 5. So if we're trying to evaluate sine of theta over 2, that means we want this formula. That means we need to know what cosine of theta is. So let's redraw that triangle, maybe a little smaller so I have room to work. 3rd quadrant. Sine is the opposite, divided by the hypotenuse. So using a squared plus b squared equals c squared, we get that the adjacent is 3. and it's a negative 3 because we're going backwards on the x-axis. So now we can say what cosine of theta is. Now that we have the triangle drawn, cosine is negative 3 over 5, the adjacent over the hypotenuse. And so we plug that into the formula using positive, because we said our final answer is going to be positive at the beginning. It's 1 minus cosine of theta over 2, using this formula right here. And to simplify, so that's 5 over 5. That's plus too, so it's going to be 8 over 5 in the top. Still simplifying, so that's 8 over 5 divided by 2. That's the same thing as multiplying by 1/2. So we're going to say 4 over 5, and then you could apply the square root to the top and to the denominator. So that's 2 over the square root of 5, which is the same thing as 2 square roots of 5 over 5, because you can multiply the top and the bottom by the square root of 5. So 2 square roots of 5, I put s, 2 square roots of 5 over 5.